In this lecture, we're going to talk about long-run averages. What happens if you repeat an experiment lots of times and look at the average value that you get? Like so many things in probability theory, a good way to understand it is again to think about flipping an ordinary coin that has probability 50-50 of coming up heads or tails. So if I flip it just once, the probability of heads is 50%. Well, we already know if I flip it twice, then a quarter of the time I won't get any heads, and half the time I'll get one head, and a quarter of the time I'll get two heads. But what if I flip it lots and lots of times and look at the fraction of heads that I get? You might think as you flip it more and more, the fraction of heads should get closer and closer to a half. And indeed, in this lecture, we'll see that that's so, and we'll understand better how that works. So to start off, let's again imagine flipping a coin twice, and I've graphed here the probabilities for the fraction of heads that you'll get. So a quarter of the time you won't get any heads, half the time you'll get half of them heads, and a quarter of the time you'll get all heads. Simple enough. If we flip 3 coins, well, we worked out those probabilities before too, and we can see here that there's probability 1/8 of getting no heads, or 3/8 of getting a third heads, 1 out of 3, or 3/8 of getting 2/3 heads, or 2 heads out of 3, and 1/8 probability of getting all heads, 3 out of 3. What if I flip a coin 10 times? So here's a graph when I've flipped 10 coins and looked at the fraction of heads that I get. And we can see from this graph that the most likely fractions are fractions which are close to a half, corresponding to 5 heads out of 10. Now, a little bit less or a little bit more than half heads, corresponding to 4 heads or maybe 6 heads out of 10, are also quite likely. But getting no heads or 1 head, or getting 9 heads or 10 heads out of 10 are very unlikely. If we flip even more coins, we can see this more clearly. Here's a graph of the probabilities when we flip 30 coins. And we see now that sure enough, the probabilities closest to the middle, closest to half of the flips being heads, are indeed the highest ones. We can also start to see something else. We can see a little bit about the shape of the graph of these probabilities. We can see that it's highest in the middle, and it falls off to the sides in a nice round shape that might look a bit familiar. If we flip 100 coins, we can look at the graph again. The first thing we see is that all the individual probabilities are getting quite small because there's all different possible results you could get for the fraction of heads when you flip 100 coins. But we can also see the shape, and if we stretch it out, here's another version of the same graph, just stretched out so we can see the probabilities better. And we see, sure enough, we've got this sort of curve shape, which should remind you of the density for the normal distribution that we saw in the last lecture. So what can we say so far? Well, we say that as we flip more and more coins, sure enough, the fraction of heads seems to get closer and closer to being a half, which is what you might expect. But also, if we look at the graph of the probabilities, that is the distribution of the fraction of heads that we get, it looks more and more like it has this curve shape, kind of like the normal distribution. Now, what are the general conclusions that we can make here? Well, if you flip a coin infinitely often, you'll get half heads. But remember, we also had that characteristic shape. And that's what's called the central limit theorem, and it's extremely important in statistics. And it says that if you repeat an experiment over and over and average up the results, then the distribution of the probabilities for that average will get closer and closer to being normally distributed, or to having the bell-shaped curve. So it says that that normal distribution comes up approximately all over the place whenever we're taking anything that could be viewed as any kind of an average. And we'll see as we go on that that allows us to make all sorts of inferences in statistics.